All right, so we are doing lesson 3.1. We are going to be talking about functions. The first thing we have to talk about in reference to functions is, what is a function? How can you tell if something is not a function? The vertical line test is going to probably be the easiest way to determine if you have a function or not. And basically what it states is, you should be able to draw a vertical line, so a line up and down, anywhere on the graph of the function, and it will only touch one point, or none, one or none, but not more than one. So this over here is a function, because no matter where I draw my vertical line, I will always only be touching one point. This over here is not a function. All it takes is one time touching 2 points on the line, and it's automatically not a function. So if I was to do the vertical line test for this graph here, I'm done. Okay, it already did not pass the test because I hit this point up here and this point down here at the same time with the same line. So you're only allowed to touch one point on the graph when you draw a vertical line through the graph. So this will be great if you have your functions represented as graphs. If you don't, there are some other options. But first, let's keep practicing this one. So let's go to the next page. We got our first example. And we want to determine if each of these is a function or not. Generally, you can kind of visualize if there will be a spot where a vertical line will cut through 2 points. And you kind of want to hit that one first. So in looking at A, I'm noticing there's these 2 points here. If I draw my vertical line through them, what do you know? I hit them. So I don't even have to do any more. I'm going to say no. This is not a function. And then it also says to explain. So it's not a function because it does not pass the vertical line test. And then we want to look at B. I am not noticing right away that there are any spots where if I draw a vertical line that it will pass through 2 points. So I'm just going to try a few. Nope. Nope. It looks like all the vertical lines that I drew only hit the graph once. So I'm going to say yes, this is a function because it passes the vertical line test. So you take a moment and determine whether these 2 bottom ones are not or are functions. Okay, so hopefully these are the results that you got. Number 1 is not a function because it does not pass the vertical line test. However, number 2 is a function because it does pass the vertical line test. Alrighty? Let's move on. And we're going to talk about domain and range. Domain and range is going to be a very important concept throughout the rest of the year. We are starting now with chapter 3. We're starting our linear functions unit. But we are going to do all different types of functions this year. And with each type that we learn, we will do domain and range. So taking the time to really solidly understand this concept now is going to help you a lot in the long run, because it's going to keep coming back and keep coming back and keep coming back all year. So the domain of a function is the set of all possible input values. Input values are your x values. The range of a function is the set of all possible output values, which are your y values. So they will be referred to as input-output. They could be referred to as x and y. But just know, input is x, output is y. Domain is x, range is y. So let's take a look at these two graphs down here at the bottom, and we are going to define or find the domain and range of each of these. When you have separate points like this, it actually makes it a little easier to find your domain and range, because they're just points. So my domain, which are my x values, you always go least to greatest. You always write your domain in order. Remember when we were talking about inequalities? We always have to write our solutions to the inequalities from least to greatest. This is that same type of deal, and you will see why in a minute. So for our domain here, domain is x. Here's our x-axis. So I'm going to start at the least point on my x-axis, which is as far left as I can go, which will be this point. What is the x value of this point right here? -3. Then let's go to the next least one, this one. What's my x value here? -1. This one has an x value of 1, and this one has an x value of 3. So my domain for this function is 3, -1, 1, 3. Let's do the range now. This is my y-axis. It goes up and down. I want to start at the least point, which will be as far down as possible, so it'll once again be this point. What is the y value of this point? It is -2. What is the y value of the next point? 0. And the next one? And the next one? It is 4. So this is how I would write my domain and range for this function. But look at the graph of B. The graph of B is a little different. These are separate points here. These points are all connected. So the way that we're actually going to write our domains and range, when you have points that are connected by a line like this, is you're going to use inequalities. Once again, we have to go from least to greatest. Domain talks about our x values. That is this axis right here. So we want to go, how far back along this axis does the first point go? Well, that's this one. And it comes up and hits my x-axis at -2. So -2 is as low as my domain goes. My highest point, my furthest right point, I suppose, hits here at 3. So my domain is actually going to be the range of values from -2 to 3. So how would I write that as a compound inequality? -2 is less than or equal to x, which is less than or equal to 3. And they're or equal to, because you can see that these last points here are closed. If it was open, that would be different. Another reason why it's important to go from least to greatest. Domains and ranges can be written as inequalities. Inequalities must be written least to greatest. So it's all that chapter 2 stuff that we just did, it's coming back. My range are y values. So what is my lowest point that is going to hit the y-axis, and what is the highest point? Well, this is the lowest point on my graph, and it hits the y-axis right here at -1. This is the highest point on my graph, and it hits the y-axis right here at 2. So range is from -1 to +2. So how am I going to write that? Essentially the same way I wrote this, but range is not x, range is y. So -1 is less than or equal to y, which is less than or equal to 2, and that will be my range for this graph. The point that I'm trying to make with domain and range that you guys tend to get confused on easiest is we are looking for the where these points would touch the x or y axis. Okay? This does touch the x-axis, but it's not an endpoint for our domain. This does touch the y-axis, but it's not an endpoint for our range. You almost have to take your graph and extend it through the part of the axis that you are doing. X-axis for domain, y-axis for range, to see like where is it going. Even though it's not on the axis, its location relative to the axis is what we need to know. Questions? All right. Then you have these two do-it-yourselves. If you're watching via video, go ahead and post the video, pause the video, try to do it yourself, and then click play when you are ready to see if you got them right. So our domain for this one, where our x values would hit the x-axis, is at -2, 1, 0, 1, and 2. Where our y values would hit the axis are 4, 2, 0. This one hits at 2 again, and this one hits at 4 again. You do not need to put repeat numbers down in domain and ranges like this. Okay, so just leaving it as 4, 2, 0 is good. For this one, our range is 1 is less than or equal to x, which is less than or equal to 5. We are not necessarily looking at where our graph is starting and ending. We are not following curves from this starting point to this ending point. We are simply looking at what is the lowest point on the graph, what is the highest point on the graph, and where would those touch either the x or the y axis. So the domain, here's the lowest coming in at 1, here's the highest coming in at 2, least being 1, greatest being 5. So my domain is from 1 to 5. It doesn't matter what happens in between there. This graph can look like this, 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 whatever. It's going from 1 to 5. For my range, now we are looking at the highest and lowest point on the graph as referencing the y-axis. The highest point would be up here at 4, the lowest point being down here at 0. It doesn't matter that it comes back up and hits 4 again, right? We learned right here, no repeats. We just want to know what is the highest point on the graph and the lowest point on the graph. So it's 0 to 4, so my range is from 0 to 4. That's going to be the tricky part of domain and range. You guys want to look at the shape of the graph and you want to follow along the curve and you want to go from the starting point to the ending point, but you're not doing that. You're literally drawing imaginary lines to whatever axis it is, whether you are doing domain and range or range. Okay? And we had a question about the range here. Least to greatest would be 0 to 4, not 4 to 0. So we want to switch that one around so we're least to greatest. All right. Moving on. Let's talk about independent and dependent variables. Independent variables represent the input values. Which values were the input values, guys? The x of a function, because it can be any value. And know how x can always be anything. We're always like, pretend that x is anything. Any value in the domain. Dependent variables represent the output values, or the y values, because the output depends on the input. You can change up whatever you want the input to be. That will then affect what the output is. So the y depends on the x. Let's take a look at this next example. We've been given this function, and it represents the amount of fluid of juice remaining in a bottle after you take a certain number of gulps. It says the fluid in ounces is y, the gulps are x. So we want to identify the independent and dependent variables. This is much more than x, y. Do not tell me the independent value, the independent variable is x. It always is x. How does the independent variable, what is specific to this situation? So sure, it's x. But what does x represent here? In this specific story problem? Yes, the number of gulps taken. And then the dependent variable which is y. What is that going to be referencing in this specific situation?
The amount of juice remaining. Yes, the amount.
Yes. The ounces of juice that remain. So that's why it's independent and dependent. The amount of juice that's in a bottle it depends on how many sips you take, right? So independent, dependent. The domain is 0, 1, 2, 3, and 4. What is the range? We are going to plug these in to our equation and find out. So the domain is this. So these are my x values. I have an x of 0, an x of 1, an x of 2, an x of 3, and an x of 4. What are the corresponding y values going to be? Let's find out. So I've got this one, which will give me 12. I got this one, which will give me 9. I got this one, which will give me 6. I got this one, which will give me 3. And I got this one, which will give me 0. So now I've substituted it in, each x value in to find its corresponding y values. And now my range, put them in order, 0, 3, 6, 9, 12. So that is my range. Alrighty. Last one. So once again, if you're watching via video, pause it. Try to figure this one out on your own. When you have it completed, press play and see if your solution matches ours. So in this case, our independent variable was m, standing for the time in minutes of how long your oven had been preheating. The dependent variable is T, which is the temperature of the oven in degrees Fahrenheit. How do we figure out the domain and range? Well, it says that the oven temperature is going to be 350. So I know that my maximum temperature is 350. What then is my minimum temperature? Well, in looking at my equation up here, my range always depends on the domain. M is time in minutes. First, I guess, let's see how long it took to get this oven to 350 degrees. So I'm going to plug in 350 into my equation and then solve for m. So I'll subtract 65, divide by 19, and I'll get that m is 15 minutes. So essentially that's letting me know that it takes 15 minutes to warm this oven up to 350 degrees. So I've got my maximums. What about my minimums? Well, it's time. Doesn't the clock start ticking the moment that you turn the oven on to start preheating?
Yeah.
Yeah. And then can time be negative?
No.
No. So our lowest time is 0. At 0 minutes, we are just turning the oven on. And then it will take 15 minutes to get it preheated to 350. So what is the matching range for 0? We can plug it into our equation again. So if 19 is 0, 19 times 0 plus 65, that means the lowest temperature that the oven is at 65. And that kind of makes sense, guys. How hot do you keep your house? Like, are we walking around in houses that are 0 degrees? No. And your oven's inside your house. So there is a baseline for when you open your oven door, you don't get like a blast of cold air, right? So your oven is going to start somewhere. 65 is where this one particularly starts at. So that's our minimum there. And we write our domain and range as compound inequalities just like this. So the domain of this situation is 0 minutes to 15 minutes. And the range is 65 degrees to 350 degrees.